So next up, we're looking harder at polynomials and how to graph them. Now, we've already done some of this already, right? So, actually, on the schedule, the next thing I'm scheduled to talk about is quadratic functions and models. I don't really have much to say about that, except that what's a quadratic function? What's a quadratic function? It's just a function whose formula is given by a quadratic, right? And if you were to complete the square on this, right, this would be a times x squared plus b over a, x plus c over a, and a little bit of algebra here. This is a times x plus b over 2a quantity squared. So to be fair, I have to subtract b squared over 4a squared. Still got this c over a over here. And fine, if I clean this up just a bit more, this gives me a times x plus b over 2a quantity squared minus, what's this term over here? Multiply the a back through, I get a b squared over 4a plus c. Oh man, was there something offensive? Something in the math? No? She packed up her stuff though. She's not coming back. She's going to the restroom with her bag. I mean, that's very optimistic. Thank you guys for your vote of in her dorm. Going to the bathroom in her dorm. Okay. Let's see here. So this is, well, if we write this as b squared, excuse me, b squared, well, anyway, I can just stick with that. I'm going to stick with the formula above. You guys got me all distracted. My point to you is you could rewrite a given quadratic function in this way, and when you do that, we can, go back to what did our graph of a quadratic look like? Remember, k plus a times x minus h squared, right? So if you look at the above, you can tell me what the formula is for h and for k, right? H is minus b over 2a, right? And what's k? What's the formula for? I never gave you a formula for k before. But now, if you look at this, you can see that the formula for k is apparently c minus b squared over 2a. Where did the k come from? Have I never talked about how to graph a quadratic in here?
I don't recall.
No? Okay, you worry me. There exists the possibility I'm thinking of the other course. So you could push me to that. I am very gullible. But I never wrote the formula for k down before, but there it is. So
What's the h?
h minus b over 2a. So these are the vertex, exactly. So all I'm doing here is comparing. If you look at this formula versus that, and if you look at this versus that, it gives me two formulas. Now, if this is a quadratic model, it's going to have a maximum or a minimum, right? Depending on whether a is positive or negative. And that's pretty much all I can tell you. is, if I graph the quadratic, it looks something like, maybe it looks like this, right? And if I wanted to tell you what the point is right there, that point is h comma k, right? With the formula given right above. And so that would tell you where the maximum value for the quadratic function is the maximum value is k, right? And where does it happen? It happens at x equals to h. For example, we had f of x equal to, I don't know, 3x squared minus 7x plus 2, then I can tell you h equals to minus b over 2a, right? Which is what here? Minus a minus 7 divided by 2 times 3. So it looks like 7/6. So the first order of business here, guys, is I need to be able to read from this what a, b, and c are. A is equal to what? B is equal to what? C is equal to what?
3 negatives
And 2. All right, good. And how about k? What's k equal to? K is the y coordinate of the vertex, but I just worked out this formula here for you. It's c minus b squared over 4a, which is kind of nice because then we can just plug in 2 minus 7 squared divided by 4 times 3. So apparently it's 2 minus 49 over 12, which is 24 minus 49 over 12, which is minus 25, I think, over 12. So if I asked you the question, what's the, this is a quadratic model, what's the maximum value that, f of x takes? What's the minimum value for f of x? What would you answer those questions with? Let me graph. So apparently it's got the vertex is at like 7/6 minus 25/12, which is about minus 2 point whatever. It's like here-ish. So here's the graph. The y-intercept is about 2, so that's kind of here-ish. I don't know. So what's the max for f of x? Oh, 2 is 24 over 12. I'm just converting fractions so I can add them. 2 is 24/12. So like I got to... That's a good question. So my question is, what's the maximum value for f of x? I mean, it's kind of like asking the question, can you trust a politician? Yeah, sure. No, right. No, but yes. You're like, it depends on the politician. I'm not going to have such a jaded view. There must exist a good politician somewhere, right? You're like, I'm a politician, you can trust me. So then I'd have to really think about my life. No, the answer is no. There's no max. It opens up. It keeps going and going and going and going. There's no maximum. Yeah, max is infinity if you like. So I would say no. There is no max. This question is a wrong question, right? What's the minimum for f of x? That point right there, it's k. Yeah, it's k. So the minimum for f of x is minus 25 over 12. That's the minimum. That's the global minimum. you know, a much quicker second example, we don't need all this fancy stuff for. If we have f of x equals to 3 minus x squared, what's the maximum, what's the minimum for this function? Can we graph that? It's got a y-intercept of what? 3? And if we factor this, this is, I mean, we can factor this, good grief, square root of 3 minus x, square root of 3 plus x, right? So it's got y-intercepts about plus or minus 1.7. That's the square root of 3 is about 1.7. Yeah, so it opens down. I heard one of you say it opens down. So what do you think? What's the answer to my question? Is there a max? Yes, and it is? Who said that? Who said that? Oh, Steven said it. Okay, 3. Steven says 3. I'll allow it. Minimum? No. I mean, there is no minimum. None exists. That's pretty much all there is to quadratic models. I mean, of course, you can add a word problem to it and, you know, find a specific real-world example which would come up with this kind of formula, you know. The most popular one I can think of is this one, you know. Just gravity, right? Like the quadratic model for gravity is y of t equals y naught minus 1/2 gt squared. Oh, sorry, missed a term. Y naught plus v naught t minus 1/2 gt squared. This is, you know, probably the most famous quadratic model. That's constant acceleration due to gravity. It says that the position, the y position, is the initial velocity times time minus 1/2 gt squared. So that's that. I mean, that's what that formula says. And so because the coefficient of the quadratic, the squared term, is negative, it's like this. It's got a maximum. You know, there is a maximum height the marker goes to, right? Sad. So yeah. All right. So that's quadratic functions. Let's move on here. So I don't want to hurry my discussion of graphing polynomials because I want to take a good about, I don't know, 20 minutes to do that, and probably maybe longer. We've dabbled in it before. There's a homework question you had that covered this already, but it was just a sketch. It wasn't careful, right? I'm going to try to be much more careful with my graphing of polynomials coming up, all right?
Yes.
But, thank you. The other topic that's on the soon coming agenda is dividing polynomials. And I think it's good to do an example of that here with the time that remains. So let's look at long division of numbers before we do this. You guys remember how this goes? What if I had, say, 537 and I wanted to divide by 20? What do I do? 20, yeah. How many times 20 go into 53? Dose, I like it. So 2 times 20 is 40, right? And then that gives me what?
2 goes over 30 at the top, right?
2 goes.
When you get going to 5,
Oh, am I?
you're going into 53, so you have to put it over the last one.
Okay. Interesting. Fine. I mean, I don't think we disagree on the answer. I just would write the 2 here rather than there. It's okay. I don't think we're going to have a disagreement. 137, what do you got? How many times? 6. All right, so I put 6 here. We all can agree on that? All right, good. 120. I agree with myself all the time. 17. So once we get to a number which is what? Smaller than the divisor, game over, end of story, we're done, right? This is the remainder. And so what this little calculation means is what? This means that 537 divided by 20 is equal to 26 plus the remainder, which in this case is 17, divided by, where was I? 20, yeah. And so that's what that means. We can actually do the same thing with polynomials. So check this out. If I have x squared plus 1, and I want to divide it into x to the fourth plus 3x cubed minus x plus 2, I can do that. You'll forgive me, but I'm going to write x squared right here because otherwise I go nuts. You guys are making me write the 2 over here. That goes against my sensibilities. So let's see here. What? Oh, yeah, you got me. All right, so you want me to do that now before I write it out? Yes. All right. So you guys are like, you got some kind of, oh man, I forgot what I wrote there. We can make it anything. What was it? 2x plus what? Plus 1? Whatever. Anyway, now it's that. Okay. Once I erase it, it's my memory's it's gone. Anyway, so x squared times x squared plus 1 is what? That's x to the fourth plus x squared, right? So you're right. I got to put it over here, don't I? That's your point. I like it. So I subtract, and I get the x to the fourth goes away. I get a 3x cubed minus x squared minus 2x plus 1, right? And then how do I get x squared to get the 3x cubed? How do I cancel that? What do I need? 3x plus 3x. You guys already know this? Goodness. How are you guys good at this? You have gotten confused about far simpler things in here. This is very unsettling to me. To me, this feels sophisticated.
That was easy to me.
This is easy? What's going on here? It's upside down. Yeah, the practice problem. So, but the 3x times x squared, what I just did here is multiply this out, right? That's 3x cubed plus 3x. That's why I wrote that down here, right? I'm actually multiplying this times that and putting it here, matching up the corresponding powers, right? 3x squared canceled. I get minus x squared minus 5x, right? Plus 1, right? Because I have to subtract. I'm always subtracting, right? I mean, a lot of times I haven't done it. I actually like to put notation like this here, just to emphasize that I'm subtracting. And I like to do the same up here, actually, honestly, because we're subtracting. Remember, division is what? It's repeated subtraction. Someone should have told you that when you were young and impressionable. Let's see here. Minus 1. You're still young? You're still impressionable? So you're not jaded, and you have hope for the world? You got gray hairs? I don't know how we got there, but okay. Minus x squared minus 1. And now we take the difference again, right? And what's that give us? And when are we done here? What are the rules? In regular numerical division, it's when the number is less than the divisor, right? In division of polynomials, you're done when the degree of what's left over is smaller than the degree of the divisor. So here the degree is 2. Once we get something lower than 2, game over. So minus 5x looks like plus 2, right? And that right there, guys, is the remainder. What does this mean? What this calculation means is that x to the fourth plus 3x cubed minus 2x plus 1 divided by x squared plus 1, guess what? That's equal to, well, x squared plus 3x minus 1 minus, well, rather plus 2 minus 5x divided by x squared plus 1. And this is what's known as polynomial long division, which is just fancy speak for dividing polynomials just like you divide numbers. When can you do polynomial long division? Like, can you do it for quadratics? Yeah. We just did it for quadratic. Could you do it for a linear term? Like if I had x plus 1 there, could I divide? Could do that. Yeah. In fact, you can pretty much do this for any polynomial. This is a general method. You've also been taught something called synthetic division. Synthetic division would not allow you to do this. Synthetic division is only good for dividing by linear terms. And for that reason, I refuse to teach it. So, synthetic division is easier. You can't even do synthetic division with this. Well, but if you want, I mean, synthetic division here, you'd have to factor x squared plus 1 to do synthetic division. Can you factor x? It's okay. Oh, I like it. I have just been granted permission. I have just been granted permission to factor x squared plus 1. Thank you. So I am now permitted this factorization in this course. Thank you, Kimberly. I appreciate it. Now I can do all my math in the complex plane. Woohoo! Much better. So we'll do more of this. Anyway, thanks, guys. I hope you did well in test. If not, do not despair. There's still the final. And I did not say anything about a bonus quiz, too. I have enough grading already.